Schema inference, also known as automatic schema detection, is a process in which a function analyzes the dataset structure and content of the dataset to automatically determine the data types and structure of the data without explicitly user specification. In other words, it's the ability of a function to understand and deduce the schema structure of the data from the data itself. This process saves significant manual effort and time. Users don't need to manually specify the schema for each column, especially in case of large and complex datasets. The infer schema is a table function that comes pre-built in Snowflake and has been available for a while. Now, it also supports inferring CSV and JSON files in both internal and external stages. For skilled Snowflake developers, the SQL construct displayed on the screen seems straightforward. The table function is called with input parameters and results are shown. However, there are some important aspects you might not be aware of, such as its behavior with a large dataset in the stage location, how it treats column headers, what happens in case of errors and how to resolve them, and whether it supports all data type, among other things. We will also learn how to write an automation code that utilizes this infer schema function, leading to a 95% reduction in your development effort to load the data into Snowflake tables directly. This video tutorials offers a wealth of learning. It is split into 10 short sections featuring automation code, Snowpark Python API. In addition to explaining the theory, we will also show you practical demonstration for each scenario using the Snowflake free trial edition. You can get the sample data files, SQL scripts, and tree map by visiting my blog page. The link to the blog page is provided in the description section below. Here is an exciting bonus for you. If you stick around until the end of this video, you will receive a link that grants you free access to the entire automation code written using Snowpark Python API. Welcome back to my channel Data Engineering Simplified and to this Power of Infer-Schema for Staged CSV File tutorial. Before we proceed, I have a quick note to share. These videos are recorded in 4K resolution. Follow the instructions for better resolution and to learn this video faster. A quick announcement. I have published more than 150 videos covering different Snowflake topics under different playlists. And if you find it hard to search a specific topic, use this summary card for quick search. Download instructions are given below. For any additional queries or specific question, feel free to drop me a note to my Instagram account. If you would like to practice the infer schema, all the SQL script and sample CSV file used in this video can be found in my blog page. The link for the blog page is available in the description section. Let's explore the topics we will cover and the skills we will practice in this video tutorial. Part 1 of this video will discuss the SQL construct of the infer schema table function. Second part of this video will showcase how this function performs with various file size. Does it take same time for 100 records versus 1 million records? In the third part of this video, the focus will be on data type inferences, specifically whether this function can infer array and variant data types. In the fourth part of this video, various scenarios will be simulated by using different kind of CSV files in the stage location. By observing the behavior and respective error messages, you will become familiar with what works and what does not work. The fifth and the sixth parts will focus on infer schema input and their outputs. In the seventh part, we will explore the dissimilarities between parse header parameter versus skip header parameter, understanding how they behave differently and when to use and when not to use them. In the eighth segment, we will showcase the process of creating a table using template keyword on the top of infer schema function. This allows us to directly create a table without needing to issue any DDL statements. Additionally, we will explore any potential limitation that may arise from using this approach. In the ninth part, we will summarize all the limitations associated with using the infer schema function with the CSV files. Lastly, in the 10th segment of this video, we will present an automation script that can create hundreds of tables, load all the dataset within a minute from your stage location to your Snowflake tables, and save up to 95% of your development effort using Snowpark Python API. This program can also generate SQL files if you want to follow CI/CD approach to version control them. So let's start. Throughout this video, I am going to use free trial edition of Snowflake, and let's jump into our Snowsite worksheet. So this is my part 1 worksheet in my Snowsite web UI. Let's quickly change our context where I am going to use demo database, sales schema, and compute underscore WH virtual warehouse. So all these statements are executed successfully. I am already using system admin as a role. Throughout this tutorial, I am going to use system admin as a role. Make sure that I am consistent with my object creation and do not get into any issues with respect to my roles and securities. If you look into the line number 9, where I am using a keyword called Infer-Schema, and this Infer-Schema is a table function, where in this example, this function is taking two parameters. The first parameter is a location, where I have specified the location of my CSV file, and the second input parameter is my file format. I have to tell this function what kind of file is being used for Infer-Schema, whether it is CSV, JSON, Parquet, Avro, or ORC. If you do not specify this file format parameter, this entire SQL statement will end with an error. Since it is a table function, I have to use select star from a table, and within the table I have to provide this function name along with the input parameter. And before I run this statement, let me check if I have data available in this order underscore data stage location. I can see I have this data set available, which is called records equals to 10 order underscore data underscore 10.csv. I have followed this naming convention where 10 represent number of records. If you look into the sample data set, this is how it looks like. The first line represents the column header, which has total 9 fields, and starting from row number 2 to row number 11 is actually the data set. And this is a comma separated values, and that's why it is named as order underscore data underscore 10.csv. So while using the Infer-Schema, I am going to read this file, and this line number 1 headers will be extracted along with the data type present in this sample file. So let's execute this SQL statement. Now I can see the first field is called column name and the second field is called type, where the field 1 captures all the column name from my CSV file, and that CSV file is residing under the named stage called order underscore data. And if you pay attention, this Infer-Schema has precisely detected the number, date, time, text, boolean data types, and it has also included the precision. So in case of order ID, it starts with 1 and it ends with 10, and that's why it has given, and that's why it has identified the data type for order ID is number with 2, 0. Similarly, the order price, and if you look into the order price, the total length of this number is 6 followed by 2 precision character, and here it has captured the order price correctly. And if I look into the existing customer flag, here my existing customer, which is either false or a true, and Snowflake Infer-Schema has detected the data type correctly, and it has assigned data type boolean for existing customer. We have learned in another episode how you can query the stage location file, and to query the stage location file, I have to create a file format, and then I can use the dollar notation. I'm going to create a file format called myFileFormat01, where I am specifying skip header equals to 1. What it means that it will skip the first row and will consider that row as a header. So my file format is created successfully. Let's describe this file format. So I can see skip header equals to 1, and there are few more parameters which has been overwritten. And if I look, field optionally enclosed by is also overwritten. I have written this select statement where my file format is equals to file format underscore 1, and I am using this file location to query the data. Let's run it. Here is the result, where first is also text, second is also text, and third is also text, and like this is also text. So by running a dollar notation query on the top of your stage location, you can verify whether your schema detection has generated the right output or not. Now what happens if I use this file format for my infer schema? Let's see how does it behave. When I use a standard file format for my infer schema table function, it does not detect the first row as a header, and it follows a very standard procedure of specifying column 1, column 2, column 3 with notation C1, C2, C3, C4 and Cn, and that's what we can see on the screen. So we will understand later part of this video so you can detect your schema correctly. Let's quickly run this query and understand which region and which version of Snowflake we are using here. I'm using AWS US West 2 and my current Snowflake version is 7.25.0. So the infer schema with the CSV file as well as with the JSON file is in a public preview at the time of recording, and most likely the core behavior of this infer schema table function will stay same. However, some changes may happen in future. So if you see a different behavior from the behavior what I am going to demonstrate or have demonstrated so far, please make sure you go and check the Snowflake documentation. There is another feature which Snowflake has provided that helps you to create a table using infer schema table function, and that is called using template statement. If you look into this SQL statement starting from line number 58 to line number 66, we are primarily using this table function where we are passing the location followed by file format, and instead of doing a select star, I am primarily constructing a list of JSON element, and then using template keyword or statement, I am creating a table called my order table. Let's run this statement. This statement is pretty simple. The later part of this video will cover the detailed explanation of this statement. Now let's run this statement. So the status of my statement says my order table successfully created. It has taken 544 millisecond, where 99 millisecond is used to read the external file, 131 millisecond is used for compilation, and 314 millisecond is used for execution. Since we are going to use different file size in the next part of this video to understand the performance, that's why I thought of displaying this number before we jump to the next part of this video. Let's try to describe the table. Right now, infer schema cannot detect primary key and unique key. Maybe these features might be added in future. Now the next question you will have in your mind, does this table creation populate data? Let's run the select statement. So I do not have any data set. Let's quickly see what is being recorded in our query activity. So I am in my query history page and this is the query. Let's go to the query detail. So this is my query profile page, and which has taken two steps. The first step detects the schema. So it does this external scan, then it scan all the row set, followed by it does the aggregation, and then it applies sort function, aggregate function, and then generate a result which is nothing but array aggregate. And then in the second step, it creates a table. Creation of table just took 97 millisecond. However, schema detection has taken 218 millisecond. And if I look into the infer schema function, let's see how much time it has taken. Here, I do not have two steps. I have only single step, and this step has taken 256 millisecond. It looks like Snowflake has internally used this schema detection query to reduce the total execution time from 256 millisecond to 218 millisecond. Let's go to the part 2. We will use the different file size and understand the performance of infer schema. Does it give the same performance for 10 records versus 1 million record? The second part of this video will showcase how this function performs with various file size. Does it take same time for 100 records versus 1 million record? This is my second worksheet. We are going to try out with 4 different data files. The first data file is having 10 record, second data file is having 1000 record, third file is having 10,000 record, and finally we'll try with 1 million record, followed by data available in multiple files in a partition format with exactly 1 million record. So let me create a file format called myFileFormat02, and this file format is having a parameter parse header equals to true. So it will parse the first line as a header line. Let me create this. So my file format got created successfully. Let's list all the files which are available in order underscore data stage location. And this is the first file where it has only 10 records available, followed by I have another data file which has 1000 record, another data file which has 10,000 record, and we have a data set which has 1 million record as a single file. And you can see the size of the data file increasing from 1k to 10k to 1 million record. I just want to make sure that we are not using the cache feature, otherwise it would be difficult to understand why a particular infer schema is taking longer or a shorter duration for the SQL execution. So let me set this value to false. For each of this performance testing, I am going to use a separate virtual warehouse. So we are also not using warehouse level caching. First, I will try to run the infer-schema function on the dataset which has only 10 record. Let me choose virtual warehouse 01. I can see here this is my virtual warehouse 01. Now I am going to execute the infer-schema on 10 record CSV file. It has taken 882 millisecond, where compilation time 450 second, followed by queued provision 84 millisecond, list the external file is 107 millisecond, and execution is 234 millisecond. Now the second file is having 1000 record. I am going to use virtual warehouse 2 to execute this infer-schema SQL statement. So my virtual warehouse 2 is now active, and let's run this statement. Now if you see, this execution has taken 1.2 second, which is slightly higher than the previous execution, and listing external file took 77 millisecond and execution took 285 millisecond. Good. Now going to the third scenario, where I am running the infer schema on a dataset which has 10,000 record, and I am going to choose a different virtual warehouse called virtual warehouse 03. So my warehouse is 03 now, and let's run this select statement. Whether it will take much more longer than 1000 record CSV file or maybe close to that, we don't know. Let's run it. This has taken 1.1 second, where listing external file has taken 86 second and execution has taken 560 second. Now I'm going to execute infer schema on a dataset which has 1 million record in a single file, and for that I'm going to choose virtual warehouse 04. So my virtual warehouse 04 is selected. Let's run this statement and observe the performance behavior. All the warehouses are having a size of extra small, and if you look into the result, it has taken 22 seconds to complete the infer schema SQL function. It has taken 21 seconds for execution, 99 millisecond for listing the external file, and 86 millisecond for queuing provision, and 339 millisecond for compilation. And the result looks same: column name, type, nullable, expression, and file names. And if you look into this, here the stage location is CSV records 1 million / order underscore data underscore 1m CSV file. Go to the query profile for 1 million record. So if you pay attention, it has scanned roughly 79.26 megabyte of data from external location. Here it clearly says it is 22 seconds. If I take the infer schema which has taken only 10 records, let's see how the query profile looks like. It has read close to 0 MB data. That's why overall execution ended in 717 milliseconds. If I go to 1000 record, It has taken close to 1 second and it has read 0.08 MB dataset. If I go to 10,000 record dataset, it has taken 939 millisecond, close to 1 second, and it has read 0.77 MB. So we can see a clear correlation that larger the dataset as a single file, more time the Infer-Schema takes to execute and bring the result. Now let's try to see a behavior where we have to run the Infer-Schema on a location where we have a multiple CSV file. So this is the same order table data available in a location called order underscore data slash partition CSV. Let's execute this list command. So the same 1 million record set is broken down into 10 different files and it is called part 1 to part 10. Okay, each of them is having close to. Now let's try to see how the Infer-Schema function works when we give this partition stage location as input. So it has taken close to 6 seconds to complete the Infer-Schema function, much faster compared to one single file of 1 million record. So we can see a clear difference. If you have a multiple file of a smaller chunk, it performs far better than having a single file of large number of record. Now one important thing which you have to notice. So when I am running the Infer-Schema function on a partition location, it looks like all the files are being scanned in parallel. And if you look, the order ID is being scanned from 7th part of the file. The order date is scanned from the first. Order time is scanned from the 5th file. Product is from the 4th file. Order price is from the 2nd file, and so on. So Snowflake has used some level of intelligence to parse all the dataset in parallel and pick the different column from the different file. Snowflake does not disclose how these things are being implemented. So if you see a very different behavior in future at a different version of the Snowflake, please drop me a note in the comment section so it will help our audience to understand the actual behavior as this feature becomes more and more mature over a period of time. Now let's see how much data it has read from the named stage. So it has read exactly same amount of data set from the named stage, close to 79.26, which we can compare from our previous 1 million record. However, the overall execution is much more faster. So we have understood how the Infer-Schema behaves. If you give a single file where less number of records are there, it will perform better compared to single file having a lot of record versus you have a lot of files with less number of record. According to your use case, you can decide and save a lot of cost by looking at this behavior. Now let's jump to the part 3 where we will understand how Infer-Schema infer the different data type and whether it supports array data type or a JSON data type. The first file is named as order data 10 array because it has total 10 record. And if you look into the last column, which is a mobile number, each of the customer is having 2 mobile number, and we are creating an array object and expecting this array object should be considered while Infer-Schema is executed. The second file is named as order data 10 underscore json.csv, and here my mobile number and the desk number are available in the JSON format. And finally, I have merged order date into order date and timestamp. So it has 8 columns instead of 9 columns as we have seen in other record where we have order date and order time as a 2 separate columns. So we are going to use this different data file and understand how the Infer-Schema for CSV file works. This is my part 3 worksheet and I have already loaded the data file into the stage location. Let's run this list command and see how this stage file looks like inside this stage location. Since all the data file is having a 10 record, that's why I have created a partition called records equals to 10. Data size is 1056 and this is the file name. Next scenario, we are going to check with the JSON data file. This is slightly bigger in size, 1296. And finally, I am going to run this timestamp.csv file. And this is slightly smaller, 960 size. Now let me alter the session and disable the use cached result. I'm going to use virtual warehouse 01. Now let's execute Infer-Schema where my mobile number is having an array data type and let's see what happens. This execution ends with an error saying that error with CSV header. Header defined 9 columns while data contains more columns. However, that is not the case. Since I have this extra comma, this entire piece of text is considered as a single value, and that's why Infer-Schema got confused. Now let's run the next Infer-Schema where I am going to have the JSON file inside the CSV file. Let's see how does it work. This also ended with an error saying that error with CSV header defined 9 columns while data contains more columns. And if you look into this data file, obviously it has this comma, and then comma is a delimiter. That's why this entire data set is not being treated as a single value. And if I look into my file format is already having field optionally enclosed by equals to double quote. So possibly you can try by giving those values into double quote and put your observation in the comment section below. However, if you expect this Infer-Schema for CSV should treat array object or JSON object as a variant column or object column, that is not happening as on today. Now let's run this third Infer-Schema statement where my order file is having a timestamp instead of date and time columns separately. And this should work. So this has executed successfully, and if you notice, this order date has captured the timestamp clearly. And if I go and execute the standard data set which has date and time separately, let's see how does it bring a result. So here in this case it has captured date separately and time separately, and in this case it has captured no time zone as a data type for our timestamp. And one important thing to observe, whenever it will find a timestamp field in your CSV file, it will automatically map timestamp underscore no time zone as a data type for that column. Now we have understood how the data type inferences happens when we use Infer-Schema with CSV file, and it fails to identify the array as well as JSON object which is available inside your CSV file. And what kind of messages you may expect, because the messages sometimes will confuse you or mislead you. So just make sure that you validate your file, and accordingly you can have some corrective action for your data file. Moving to the part 4, we will also see how the column names are considered and how the double quote behaves, and we will see the different kind of error messages where your number of field in the header versus number of field in the rows mismatches, and how Infer-Schema behaves in situations like that. This is my 4th worksheet, and I have already loaded 2 data files which is called column mismatch case 1 and column mismatch case 2. Let's quickly review how those data file looks like. Going back to my VS Code editor. So this is my case 1 file where the header is having total 9 columns including mobile number. However, the data set does not have the mobile number as an entry. On the other hand, I have the mobile number in the data set. However, the mobile number does not exist in my header. When I try to run Infer-Schema on these dataset, how the Infer-Schema behaves, it is very expected that the Infer-Schema will fail and complain that there is a mismatch between the column versus the number of field available in the row set. So let me run my list command to make sure that I have this dataset available. So I have order data 10 column mismatch case 1. I also have case 2. Now let's alter the session and use cached result equals to false. Now I'm going to use virtual warehouse 01. Now I am going to execute Infer-Schema on my column mismatch case 1. And it has failed, complaining that my CSV header has 9 columns while data contains 8 columns. While executing this Infer-Schema, I have used file format 02 instead of file format 01. Let's see what is the construct of file format 01. When we created file format 01, we have used skip header equals to 1 as a parameter. However, when we create the file format 2, we have used parse header equals to true as a parameter. Parse header equals to true parameter is primarily given for Infer-Schema function, and when you try to use skip header equals to 1, that is primarily when you try to load the data file from your stage location into a table, or you want to query the stage location using dollar notation, in that case you have to use skip header equals to a numeric value. Then you have to use the skip header parameter. Let me quickly describe the file format 1 and file format 2, and let's see the difference. So file format 1 says skip header equals to 1 against the default value 0, and parse header is anyhow having false value. And if I describe file format 2, and this is how it looks like. So I have skip header is not defined and parse header equals to true. And let's run this select statement on my mismatch case 1. I got my data parsed completely. However, the 9th column is null because 9th column doesn't exist in the data. However, it exists in the header. And if I change my file format from 02 to 01, let's see what happens. It has parsed all the values. However, column 9 doesn't exist. Okay. So if you are using a common file format for your infer schema as well as for your copy command, you will see a very different behavior in the execution of your infer schema. Now let's run the case 2 where column header has 8 field and the data has total 9 field. And again, I am going to use file format 02, which is primarily using parse header equals to true parameter. It also failed, saying that header identified 9 columns while your data contains more column. It does not say how many column does it contain, but it says that it contains more column. In the previous error, it clearly indicated that the number of column in the header is less than the number of column in the data rows. Now if I change this value from format 02 to format 01, let's see what happens, and I expect this will really work. Yes, it has identified the 9 column because it has skipped the header, and after skipping the header, it has really parsed the data from column 1 to column 9, and this is expected. If I run this select statement with dollar notation, it should also bring the result. Looks good. So I can see my column 9 data exists. Now let's understand if my description fields are enclosed with the double quote, how the infer schema treat that data file. And before we really run this command, let's analyze the data. So this is the file which has total 10 record and all the columns are enclosed in double quote. Let's see how does it behave when we try to parse this data through the infer schema function. Now I am running my infer schema where location is pointing to this order data 10 code.csv file, and it is using my file format 02, which has parse header equals to true. It has parsed the data correctly and all the data types are identified without any issue. And I can also run this select statement and understand how does it work. So this is also giving exactly the same data set. By looking at this result versus the infer schema, I can understand whether infer schema has done a good job or not. But what happens if I have a new line character or a different kind of escape character within my double quote? So let's say I have a file called order data 10 code. So if you look into the line number 11, I have a new line character in the mobile name. If I try to give this data set in my infer schema table function, let's see what happens. So before I execute my infer schema, I would like to run the dollar notation query and try to validate the data whether it is coming correctly or not. So if you look into the data set, Galaxy 10 is coming in a new line and Galaxy Note 10 is also coming in a new line. Here I have a double quote. So here I have a double quote and that's why the double quote has come. Looks good. Now let's execute this infer schema where my data set is having a new line character within the double quote. So it has identified the schema correctly without any issue. If you have a special character or escape character within your description field, make sure those description fields are enclosed with a double quote, as well as your file format should also have field optionally enclosed by value defined properly. And again, if you do not know how this file format and data loading works, I would request you to watch my entire data loading playlist, which covers different aspects of data loading in detail. Before I jump to the next part, I would like to show you how the double quote in the column header bring any difference when we create a table using infer schema, and the infer schema refers to this data set. So this is my create table SQL statement, which is following using template keyword. Within this we have this infer schema, which is referring the CSV file where header is also in a double quote. Let's execute it. So my table called underscore 01 is created successfully, and let's run this get DDL statement. If I click on it, expand it, so I can see all the column names are available in the lower case and they are all inside the double quote. Okay, and this is the same behavior which we have seen earlier also. Now we will quickly see if I can execute this create table statement along with infer schema if my table already exists, followed by can I create a transient table or can I create a temporary table. So I am going to re-execute this statement and let's see what happens. It says my order table already exists and it cannot create the table. So for that I have to make a modification, and with this modification let's see whether it works or not. So I am able to create my order underscore table underscore 01 with create or replace keyword. The next, can I create a transient table? So I will run create or replace transient. I used transient classifier to classify the table as a transient table, and let's see if I can create this table or not. So I managed to create a transient table, looks good. And can I create a temporary table or not? So I have specified temporary as a classifier, and let's see if I can create a temporary table or not. I can create all kind of table. If my table exists, I can use create or replace, or if I want to create a table only if the table does not exist, then I can also use if exist or if not exist keywords before I can issue this create statement. So we have covered how the error messages appear if you have a mismatch in the header row versus the data row, and what is the role of a double quote and how the column name appears if it is inside the double quote. Next two part 5 and part 6 will explain the different input parameters can be given to the infer schema when we are considering the CSV file, and we will also analyze the output of the infer schema, which we have partly seen, but we will pay little extra attention to this out. Let's try to understand the different input parameters and output value from the infer schema. So far we have already seen what all input parameters it takes and what all output it gives as a table value, but we will go a little deeper here. So if you look into the infer schema, it takes two parameters, where the first parameter is called location, where I can specify the location of my CSV file, and I can also give file format. Both these parameters are separated by comma. If I remove the comma and try to execute this statement, it will end with an error. So it says that unexpected file format on line number 10. And if I do not give the file format, let's see how does it behave. It says that not enough argument, expect 2 but got 1. So the minimum number of argument for infer schema is 2, which is a location as well as file format. Let me revert this. Now let me execute this statement once again, and this time I got a complete result where first column is called column name, followed by type, followed by nullable field, expression and file names. Right now for a CSV all the values are nullable and this field will always come true. Snowflake's future release might have this identifier where by looking into the data file it can classify whether this column can be identified as a null or not null, and accordingly this flag will change. This is expression which we use to query the external stage with dollar notation, and this double colon is used for typecasting. If you have not seen how to query the external stage or a named stage, I would request you to watch this particular chapter, which is part of my entire Snowflake playlist. And here I have the file name through which it has really parsed the data and detected the column name and the column data type. And finally it has order ID and it starts with 0 and then it specifies the order of the column. So if I replace this file with another file which has a timestamp as a data type, let's see how does it work. So it identifies the date time and timestamp correctly if it is given in appropriate format in your data file. However, if your data file does not have the date and the timestamp in appropriate format, then Snowflake will identify them as a text. Now there is another parameter called ignore case equals to true. Let's try to use this. In this case, I am using a file called case sensitive. Let's review this data file. How does it look like? So if you look into this case sensitive data file, here it is primarily targeted for your header row. If you look into this CSV file, so I have given header in upper and lower case, and I am going to use ignore case equals to true. Now let's run this statement. So this statement got executed, but if you look into the column name field, my customer name is also coming in uppercase. However, if ignore case equals to false, let's see what happens. I see my customer name is case sensitive and it is not ignoring the case. So if you have a specific requirement where you have to retain the case sensitivity of your column, make sure you use this input parameter called ignore case. Now there is another parameter which is called files, and it's the purpose of this file parameter to specify particular file which you want to scan during your infer schema. But does it work or not, that we are going to validate in this example. So we have already tried this partition file when we have validated the performance of the infer schema function. This time I am giving only two partition files, and let's see how this SQL statement works. So the SQL statement failed and it says that invalid array construct. This file input parameter considered only one file at a time, and this is applicable only for a different data file which is unstructured data type, but for a structured data type like a CSV, this file parameter takes only one entry. Let me re-execute this. Yes, it has worked correctly. So we have understood that if you give a multiple files within the bracket, it doesn't work. If you give only one file name, then the CSV file format works. However, as per the Snowflake's documentation, this is applicable only for unstructured file format types. So we have understood what is the role of location, file format, files, and ignore case, and we have also seen how the column names including uppercase and lowercase works. With ignore case, what the type column captures, what is nullable and expression column captures, file name and order ID, which actually captures the sequence of column in your data file. We have already seen the purpose of parse header, but this time we will try to use parse header and skip header by running the copy command, and we'll see the behavior, what is the impact of this parameter if not used correctly. This part of the video will primarily focus the parse header parameter and skip header parameter. I am going to create two different file format. The first file format is called skip header and the second file format is called parse header. All the parameters are exactly same except this parameter. Let's create this file format where skip header equals to 1. Now I'm going to create the second file format. So both the file formats are created successfully, and the only difference between these two file formats are this parameter skip header equals to 1 and parse header equals to true. Now what happens if I try to create a file format where both the parameters are available? Let's see what error does it throw. So it says the file format options skip header and parse header are not compatible to be used together. Now so far we have seen if you are going to use a parse header, primarily you are going to use this file format for your infer schema. So let's run my infer schema table function, and here I am giving my parse header file format and I am taking the same data file which we have used earlier. I can see all the column names and data type coming appropriately. Now if I just change my file format from parse header to skip header, let's see what happens. Since skip header value is equals to 1 in the file format definition, it has taken the column name as a C1 to C9. So even if I give this value skip header equals to 1, 2 or 5, it really doesn't matter. Now what if I remove this parameter and recreate this file format and they use this file format in infer schema? Let's see what happens. If you notice, all the data types are classified as a text because the first row itself is a header and the header is always text. So be careful if you are trying to reuse your file format where you do not have a parse header and you have the skip header value equals to 1 or skip header value equals to 0. In that case, you will get completely different result and this result does not meet your expectation. So let me recreate this file format. Now when we run a copy command, we also use a file format. And before I run a copy command, let's create the table. And before creating a table, I would like to show what role this file format plays when we are trying to query the external stage location. So I'm going to use skip header here. So my data is coming correctly because my order ID start with 1 and end with 10. If I use file format equals to parse header for the same query structure, let's see what happens. When I am going to run a query on a stage location, the file format which has attribute parse header doesn't work, and this is the error you will get it. However, if you notice, it says that this feature is available in the private preview. Now I am going to create a table called my order table, and this table is going to be created based on this Infer-Schema table function where I am using file format as a parse header. Looks good. So let me create this table. So my table has been created successfully. Now I am going to run a copy command. In this copy command, I am considering this file and using the file format parse header. Let's see what happens. You can pause the video and guess, will it run successfully? Will it end with an error? So it says invalid file format parse header is allowed only for CSV Infer-Schema and match column name private preview, okay, which is again expected. So let me change. Now I have changed my file format to skip header and now I am going to rerun my copy command. So all the 10 records loaded successfully without any issue. Let me query the table. So I have total 10 orders. The date is classified as a date and time is classified as a time and boolean value is also classified as a boolean. Good. So we have understood the role of file format when using the Infer-Schema copy command as well as querying the external stage dataset. So we have understood the role of skip header and the parse header parameters in your file format, which type of file format should be used when running a copy command and which type of file format should be used when running an Infer-Schema function. The next section of the video will understand the using template clause while creating the table via Infer-Schema function and would also explore if there are any limitations or this is my new worksheet called create table using template. We have already seen how to use using template SQL construct to create a table. Let's explore this SQL construct little more. So this is my Infer-Schema which is taking location and file format as input parameter. And before I run this structure, let me show you what output does it give. So I got column name, type, nullable, expression, file name and order ID. Looks good. Now instead of this star, if I use object construct and followed by array aggregated, this function will make a key value pair for each of the row item. All individual row item will be wrapped inside an array list. Let's run this query and see the outcome. So if I hover here, it says this is an array data type and this array is actually holding a JSON or a dictionary type where the column name is coming as a key and the value is holding the actual data set. So the name of the column is order ID, the data type is number and rest of the information is available. So if I scroll down, this is how it looks like. So your entire tabular structure is converted into a dictionary and that dictionary data is wrapped into an array. Now, if you look into this SQL, which is start from line number 13 to line number 21, where line number 15 to line number 20 is nothing but select array aggregate object construct running on the top of information schema, and then using the using template keyword, I am creating a table directly. Right now, I am creating a table where I am using a order file which has only 10 record, and let's see how much time does it take to create a table with 10 record dataset. So it took 430 milliseconds, where listing the file is 87, execution time is 253 milliseconds. Now the next question you will have in your mind, if I change the dataset to 1 million record where the table structure is exactly same, will it take less than 1 second or will it take more than 1 second? Let's try that out. I'm going to create a table called order data 1 million, and it is reading the 1 million data file to infer the schema. Let's run this SQL statement and see the result. So it took 22 seconds. For listing the external file took 86 milliseconds and execution took 22 seconds. So there is an important thing to notice. If you have a smaller data file where structure of the smaller data file is same as the structure of the large data file, always use the smaller data file, because a smaller data file takes less amount of time and it consumes less compute to infer the schema and finally create the table. Creation of a table in Snowflake is a metadata operation. However, inferring schema is not a metadata operation and Snowflake has to use the compute power to do that. So we have seen a lot of interesting thing about Infer-Schema for CSV file. Let's summarize some of the limitation what we have observed so far. So the first limitation, unnamed table stages are not supported. And if you do not know what is the unnamed table stages, I would request you to go and watch this particular video from my Snowflake tutorial playlist. With the current version of Infer-Schema for CSV file, all the columns are identified as nullable. Even if you have a non-null column in your data file, still it will be marked as a nullable. Again, these enhancements are under private preview and soon it will identify whether this column is nullable column or not nullable column. Multiple file options not supported. This support is applicable only for semi-structured data but not for CSV data. While parsing the data, Infer-Schema does not take any input where you can specify the date format. So date format is not supported. Likewise, time and timestamp format is also not supported if it is different from the standard time or timestamp format. All variation of timestamp treated as a timestamp underscore no time zone. Next, skip header and parse header properties are mutually exclusive and cannot be given together in a single file format. And if you specify parse header equals to false, the column name will come as C1, C2, C3. And the last point, using template keyword does not populate data via Infer-Schema table function. It only creates the table, it does not populate the data. So to populate data, you have to run the copy command using a different file format. So we have covered almost all properties and behavior of Infer-Schema for CSV file. We have also validated the performance for the different file size, and we have understood the limitations of Infer-Schema while it is used for CSV file. So far things looks good. But now the big question, how can I leverage this function to automate my DDL creation and also run the copy command and load the data along with generate the SQL statement which I can use for my version control if I am following the CDCI process in my project. Next section of this video will help you to write an automation script using Python API, and there we will create DDL statement, we will run a copy command, we'll load the data, and we'll also save the DDL statement as a SQL file, and we will understand how this entire small utility will boost your development productivity and you can load hundreds of tables at no time. You may ask or think, can't this automation be done using SQL statement or via stored procedure? Yes, it can be done. And will it be an easy or a complex process depends on your SQL proficiency. But yes, if you want to write this entire process using SQL statement, you can certainly do that. But I am going to use Snowpark Python API as I need to generate files in my local machine and push those DDL SQL script file to a version control system like GitHub or GitLab. This automation and Snowpark Python API program is having three core functions. The first function is to get Snowpark session using basic authentication. And if you have not seen my Snowpark playlist where I had already covered different kind of authentication, I would suggest you to go and watch my playlist after completing this video. The next function will take the output of the Infer-Schema and generate the SQL statement and create the table in the Snowflake. And finally, the function called generate copy statement will generate the copy statement dynamically and run the copy command in Snowflake environment and copy the data from the stage location into the table which is created using template keyword. I will go through the flow. However, if you do not understand the syntax, which I am not going to cover in this tutorial, you can pause the screen and try to understand the Snowpark syntax. So let's start with our main function. So line number 36 is getting the start time. So I would like to capture the start time and end time so I can see the difference to create all the tables and populating all the data from the stage location to the Snowflake tables. So the line number 37 will call Snowpark basic authentication and get the session object. Let's go to the basic authentication. Here it is using the session.builder.config method where connection parameters are passed, and finally session object is created, and that session object is returned to this caller. Here line number 40 is setting the query tag for tracking purpose, and from line number 41 to line number 44 is primarily changing the context. So all the objects will be created under database demo and sales schema, and I'm going to use compute virtual warehouse for the entire processing. Line number 47 will fetch all the stage files which are available in this location. Let's run this stage file and see what all stage files are available in this location. So this is my demo.sales schema, and let's run this list command. I can see I have total 8 dataset available where it start with customer, nation, order, order item, part supply, region, and supplier. And if you see, the data size varies. So when I run this automation program, all the tables will be created and all the data will be loaded automatically without any manual intervention. And let's quickly check whether this table exists in our schema or not. If you look into this screen, under the demo database and sales schema, I do not have any table available. Coming back to the Snowpark program, once I get all the files entries from the stage location, it will iterate through each of the file and it will construct the Infer-Schema SQL statement. This dynamically created SQL statement will finally be executed into the Snowflake, and the result will be captured here. From that result, this program will extract the column name and the type of the column, that is the 2 element which is required to construct the DDL statement. Now line number 84 and line number 85 will take this input and call a method called generate DDL and generate copy statement. Let's go and check how does it look like. So this method will take all the column name list and all the data type list along with the table name which is being prepared in this section, and the next statement will generate the copy statement. Again, it will take the name of the table, name of the stages, name of the file name, and file format. So let's go and check how this generate DDL statement looks like. So the generate DDL statement will take this input parameter where the column name and data types are coming in a list form and table name is a string value. It will iterate through all the column names and data type and it will construct a DDL statement. And this DDL statement will be sent back to the caller. And if you look into the copy statement, the copy statement table name is considered and your stage location followed by CSV path is considered followed by the file format. So both this statement will primarily generate the dynamic SQL and pass it back to the caller, and through this iteration, this SQL statement will be executed. Now from line number 87 to line number 92, the dynamically created SQL statement will be stored in the local file system. So this can be stored in your version control like GitHub or Bitbucket or GitLab. Now once my statements are ready, we can use session.sql function and pass the DDL statement, and those will be executed. And finally we'll capture the time and see the difference, how much time it has taken to populate those 8 tables with the automation script. So let me run this program. So I can see my customer table, my nation table, order item table, order table, part supply table. So I can see 1, 2, 3, 4, 5, 6, 7, 8. So it took roughly 41 seconds to create the DDL, run the copy command, load the data, and done. So no human intervention is required to create a table. If you try to create this DDL via human effort, it would take close to 45 minutes to 1 hour. So your entire 1 hour effort reduced to just 41 seconds. So here it has generated create table statement and copy statement. It has also generated for a lot of different things. Looks good. So you can certainly enhance this program and make your automation journey more successful. So you can imagine that if I have 800 tables and if I run this program in parallel, 800 table data ingestion maybe in a 30 minutes, which in general will take maybe sometime a month time. Let's go back to our Snow site and check if the tables are created and the copy command has executed successfully or not. So let me refresh this. I can see my tables are created. Looks good. Let me quickly check the customer table. So I can see my customer table is created 2 minutes ago. It has total 6K record and the size is 422. If I click on a copy history, I can see the data is loaded here. Good. If I go to the order table, here I have total 10K record. Looks good. And the copy history is also there. Looks good. And here if I go to the supplier table, I have the data and I have data loaded over here. Looks good. So let's go and check our activity. Since I have used user called Snowpark user, I will filter the queries executed through the Snowpark user. And I will also filter by query tag. So this is the query tag I have used. So let's filter by using this query tag prefix. So when I look into this screen, it says start and end. The entire process has executed in just 1 minute, and within 1 minute it has created all the table and ran the copy statement and data got loaded from your internal stage into the Snowflake. Now you can take this as a benchmark and try to validate how much effort is given by your team to develop scripts like this, which can be done by running a simple automation Snowpark Python automation script. So this is the power of Infer-Schema, and by writing a Snowpark Python API code, you can really automate and make your development lifecycle much more shorter and become super productive. And if I look into the data set, I have part supply which seems to be a big data size. Let's see how much data is populated. So I have close to 800K records on a parts. I have 200K records and order item table has 10K record. Though we have populated less number of record, but still my entire automation script has helped me to populate data using a copy command without any human intervention. This tutorial that lasted over 60 minutes, we have learned a lot about Infer-Schema for CSV files. There is still much more to explore, and you can find the topic listed here. If you come across any of the yet to explore topic in your Snowflake project, feel free to leave a comment. Happy exploring! If you have learned something valuable from this episode, don't forget to like this video. Keep learning and keep growing.